Hello everyone, what I want to do is go over quiz 5. So in this problem here, it's definitely best to draw a time diagram, which I will do right now. So before I do that, let me just draw a time diagram first. Okay, so have it's an annuity immediate, so payments are at the end of each year. So we keep going until we have the 50th year. I'll do 49.50. So we have a 50-year annuity. Payments of 1,000 are at the end of the first year. So we have 1,000, third year, 1,000, fifth year, 1,000, et cetera, and 49th year, and 1,500 at the end of the second year, fourth year, and finally, et cetera, up to the 50th year. Okay, so we have to break this up into two annuities. So let's do the 1,000 payments first. And let me actually get my calculator out. Bear with me for a second. There we go. Put it aside for now. Okay, so let me close this out. Okay, so right, so let's get the first annuity, the $1,000 here. Okay, so this is going to be 1, 3, 5, et cetera, 49, 1,000. So there's two ways to do this. It's easiest to do this using annuity dues for this one. I don't recall if annuity dues were technically done for this quiz, but I'll do it both ways. I'll do it using annuity immediate and annuity due, and we'll check that we get the same answer. So, right, so if you do this as an annuity due, this present value is going to be 1,000 a double dot 25. Okay, there's 25 two-year periods. Let me get rid of this. So as an annuity due, I guess technically, not that it matters all that much, but payment periods really end at the end of the 51st year. If we think of this as annuity due, where the beginning is t equals 1, but anyway, it's just a technical point here. Okay, so yeah, we have 25 payments, and payment periods are each year at the beginning. Sorry, every 2 years. Payments are at the beginning of every 2 years. So, so let's get kind of a side note here. Let's get what J is, the 2-year interest rate. Well, it's just 1 year of 7% growth compounded twice minus 1, and that gives me 0.1447. That is my 2-year interest rate. Sorry, 0.1449. Okay, so this gives me, let's clear TVM, and let's go to begin mode. So remember, well, I'll get rid of it, but remember how you get into annuity due mode. You go to second begin, second set, and just quit, second quit. Okay, so we have 14.49. It's my interest rate, 25 and 1,000 negative to get a positive present value. And that is going to be 7,633 and roughly 8 cents. Okay. So 7,633 and 8 cents. I'll just leave it as 8 cents because I'm running out of room here. Okay, but of course this has to be discounted by 1 year. Okay, so let's just actually multiply 1.07 to the minus 1, and we get 713 and 72 cents. Sorry, 7,133 and 72 cents. Okay. Again, I just took this here and multiplied it by 1.07 to the minus 1 after discounted by 1 year. Okay, so let's get the other one. This is a little easier. So we have 0, 2, 4, all the way up to 50, and these are 1,500, 1,500, right. So all you do here is simply take the present value, 1,500. It's an annuity immediate here. Payments are at the end of each year. With your, again, every 2-year interest rate being 0.1449. So let's see what this is. Second, clear TVM as usual. And second, clear TVM. It doesn't matter at all what order you enter stuff in. As I mentioned many times before, and I don't have a preference really. Move this up a bit. All right, 1,500 negative payment, and we get 11. Let me make sure I entered it right because I got a slightly strange answer. 25. Yeah, of course. So you always want to make sure you're not in begin mode. Probably good that I made that error. Okay. So 25 and 14. It's a bit. 0.49 interest IY. 1,500 payment, compute present value, and we get, yeah, the correct answer, roughly 10,000. So it's 10,054 cents. So the total PV is going to be the 7,633, 7,133 and 72 cents. Plus 10,054 for a total of 17,134.26. All right, so let me actually do this using annuity immediates. Don't remember. I believe we did annuity dues by this point, but anyway. It's probably good to understand at least the logic that I'm going to be doing, even if you kind of think it's a bit ass backwards, which I can't argue. It is a bit strange to do it this way. Okay, so if I do it as an annuity immediate, that's fine. But if payment periods are every 2 years, then really the beginning of the first 2-year payment period is -1. It's t equals -1. Okay, so let's just check we get the same answer, 7133 and 72 cents. So this here is 1,025. And again, even if you don't want to do it this way because you think this is kind of dumb, that's fine, but you really should understand at least how to do it this way and why you get the right answer. Okay, so this is going to be equal to, let's see what the answer is. Okay, so 25N, 14.49, interest, 1,000, negative payment. Right, so you're going to get 6,667 and roughly 3 cents. Okay, but this needs to be moved over a bit, so I guess there's no point in really writing it. So what I'm going to do is take this and multiply it by 1.07 because this is at t equals -1. I need to, have it accrue 1 year of 7% interest to get the present value at t equals 0. So just times 1.07, and lo and behold, we get exactly the same answer, as it better be. 7133 and 72 cents. Okay, so again, I'm taking this present value here and multiplying it by 1.07. Okay, so problem 2. We have 2 annuities in perpetuity that have a present value of 5,000 and a common effective annual interest rate. First one makes payments of X at the end of every 4 years, while the second one makes payment of 50 at the end of every 2 years. Find X. So I think the easiest way to do this, there's a lot of different ways you can play around with interest rates. I think the easiest thing to do is to let J be the 2-month interest rate. So you can immediately solve for J. Well, not that you really need a time diagram here, but just to make sure we're all on the same page, I'll draw it. So every 2 months, 0, 2, 4, etc. And it's in perpetuity, so it never stops. Okay, so here the present value is simply, well, the formula is 50 over your per period interest rate, which is J. Okay. Well, we're given that the present value of both of these are 5,000. So 50 over J is 5,000. So J has to be 0.01, 1%. Okay, so now let's get the 4-year interest rate. Okay, so, well, let's get the 4-year growth rate and then just subtract 1. So I have to compound 2 months of interest 6 times to get 1 year's worth of growth, and I compound 1 year's worth of growth 4 times to get 4 years of growth. Okay. So this is just going to be 6 times 4 is 24, 1.01 to the 24 minus 1, and you get 0.2697. Okay. Okay, so now this is pretty straightforward. We have, so just so we're not confused, in years, all these are X. We don't know what this is. Yeah, and I forgot the double dots here, but it doesn't really matter. Okay, so present value, again, well, is the formula. It's going to be X over your interest rate, 0.26973. And we're given that this is 5,000. So you solve for X. 1348 and 67 cents. Okay, well, yeah, all right, so hopefully that was helpful. And I remember, if I remember correctly, the scores were pretty good. B average, median, about, but a lot of people made little mistakes, and little mistakes, as I always say, can really bite you in the ass when you take exam FM. So definitely, eventually you got to wrinkle out those little mistakes. But anyway, all right, so long, take care, till next time.